We are doing some more trigonometry, only this time we're doing some inverse trig to find angles. So it's like if I give you side lengths of a triangle, or maybe just two of the side lengths, and I ask you, what are the angle measurements? Well, we're going to use what's called an inverse trig function. We talked about it in class how, let's say you type in the sine of 30 degrees. This would be like the trig function of an angle, and you get a ratio. Well, we can do the opposite and use an inverse and say the inverse of the ratio would produce the angle. You guys can see that yourself. If you type in the sine of 30 degrees, get a half. We'll go ahead and do the inverse and type in the sine inverse of the ratio, you get the angle. Okay, so it's very important to understand, like, this is an angle, this is a ratio, and you use regular trig functions. You plug in the angle to get the ratio in the triangle, or it's very much like solving an equation. You could take the sine inverse of both sides, and you go backwards. These would undo each other, and you get 30 equals the sine inverse of 0.5. So it's like the trig function of an angle equals a ratio. The inverse trig function, which will then take the ratio and bring it back to an angle. All right. Now, what you could find is which trig function do you want to use? You can use anything you want. We can find A very quickly using the Pythagorean theorem, and we'd find that A is 3. You could do the math to figure that out. Well, let's say we're talking about angle B. You know that the sine of B would equal opposite over hypotenuse. You know the cosine of B would equal adjacent over hypotenuse. You know the tangent of B would equal opposite over adjacent, 4/3. Well, we could actually find B by using the sine inverse of the ratio, or the cos inverse of this ratio, or the tan inverse of this ratio. And you can either type this into your calculator using the inverse button. Now, notice the inverse is above sine, cosine, and tangent. If you guys show up to class and you don't know this, how to type this in, I will be upset. People didn't show up today ready to go. If you type in any of these ratios, you will get the same results for your angle. See? So that's B. B is 53 degrees. We're going to say it's 53.130. Dot, 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 dot. Now you can find angle A by subtracting that from 90. Or you could say, okay, angle A, I don't know, pick a ratio. Let's pick sine. Sine of A is 3/5. So that means the sine inverse of 3/5 equals A. And you'll get that 53 point. Oh, sorry, that 36.869 that we're looking for. Okay. If this is 2, what is this? What is the angles? Why don't we just do the angles first? We could say H. Let's go to H. 4 is the hypotenuse. Make sure you label that. 2 is opposite H. Cool. So I could say the sine of h equals 2 over 4, or h equals the sine inverse of 2 over 4. The sine inverse of a half is 30 degrees. Kind of talked about that earlier. And you could just type in 2 over 4 if you want to. You know, this is 30, G has to be 60, but let's say we wanted to go with G. 2 is adjacent G. You could say the cosine of G equals 2 over 4. You could say G equals the cos inverse of 2 over 4. Takes the ratio, gives you the angle. And you get 60. Cool. How do you find G? You can use the Pythagorean theorem. You can also use trigonometry. You could say, I don't know, the sine of 60 degrees equals G over 4, 4 sine 60. If you wanted to do 4 sine 60, you can do that. Or you use the Pythagorean theorem. 4 squared minus 2 squared, square rooted. And guess what we get? Big reason why a lot of students do not do well with this unit is there's just so many things you could do. It's like, well, which way do I do it? It's like, it's up to you. It's just so many different things. Like to find E, you could use the Pythagorean theorem. You could use trigonometry. You could find D and then use that. It's like, it's all up to you. 3 is opposite D. 6 is adjacent D. 6 is opposite F. 3 is adjacent F. You could say the tangent of D equals 3/6. That means D is the tan inverse of 3/6. You could say the tangent of F is 6/3. So F is the tan inverse of 6/3. Or you could find one of these angles and then use subtract them from 180 to get the third angle, or subtract it from 90. It's all up to you. All right, so D is 26. Like some other things you should pay attention to, like bigger angle opposite the bigger side, smaller angle opposite the smaller side. These angles should add up to 90 because they're in a right triangle. The sine of angle D will equal opposite over hypotenuse. That means 3 divided by the sine of angle D. You can get that. Or you could say it's just 6 squared plus 3 squared equals E squared. 36 plus 9 is 45. 9 root 5. Excuse me. And like, this is what's cool. It's like bugs biting me. I feel like we got bugs after the rain this morning. Tiny little guys. It's really cool. Like, completely different things. 3 divided by the sine of this angle is that 3 root 5. Seemingly completely different is the same thing. This is using the Pythagorean theorem. This is using trigonometry. They're very much related to each other. It's all right. Tangent of k is 2 over 2. K will equal the tan inverse of 2 over 2, which is just 1. Same with j. Doesn't matter. K and j have to be the same. Oh, it would be 45 degrees, right? It's kind of just obvious. It's a 45, 45, 90, but it's just interesting to see the tan inverse of 1. It's 45. Yeah, if your opposite over your adjacent is 1, your opposite and your adjacent have to be the same. You have an isosceles right triangle. The sine of 45 equals 2 over L. Cross multiply, divide, L equals 2 over the sine of 45. Great. 2 squared plus 2 squared equals L squared. 8 equals L squared. L equals root 8, which is 2 root 2. 2 over the sine of 45 is the same as 2 root 2. Guys, if you're using Desmos, just really quickly, though nobody's actually paying attention to this, tan inverse of 145, okay? You go to, I think you could actually type it in, and if you say like sine inverse to the negative first, I think they read that as the inverse, and that's 2 over 2 root 2 or root 8. Yeah, so you can actually type it in with an exponent like that. Okay. Yeah, it's great. You see how these like triangles are similar to each other? Well, like K and N have to be the same. M and J have to be the same. Because you could tell they're similar triangles, guys. Like I can just tell. So watch this. Like the sine of N equals 1 over 5. N will equal the sine inverse of 1 over 5. Well, the sine of K equals 2 over 10. Well, that's the same as 1 over 5. So K equals the sine inverse of 2 over 10, which is 1 over 10, 5. You're going to get the same thing. 2 over 10 is 1 over 5. The sine inverse of 1/5 is 11.536. That's going to be angle N and angle K. If we talked about angle M, 1 is adjacent to M, 5 is the hypotenuse, we could say the cosinverse of 1/5. You could also just subtract things from 90. You do 90 minus that. Or the cosinverse of 1/5 and get that same angle. 78.643. Or 63. How do you find M? It's up to you. You can either do square root of 24, which is root 4 root 6, which is 2 root 6. That's using the Pythagorean theorem. A squared plus B squared equals C squared. Or, I don't know, you could say the tangent of anything. You can do whatever you want. Let's do cosine. Cosine of angle N equals M over 5. 5 cosine, cross multiply, divide. 5 cosine 11.536 equals M. watch this. 2 root 6. 2. Squirt. 6. Bam. Trigonometry. Pythagorean theorem. Guarantee you this is 4 root 6. Don't even have to do any work. You just know it's scaled. You can take this number, multiply it by 2. Or if you wanted to like set it up like the cosine of k equals j over 10, the cosine of 11.536 times 10. So it's like take this value and multiply by 2. What's this angle here? Well, you know that this is 2 and this is 3. Well, the tangent of that angle, because it creates a 90-degree triangle, is 3 halves. Oh, great. My angle is the tan inverse of 3 halves. What about this angle here? Well, watch this. This is now 2. This is now 3. So let's call this happy face. The tangent of happy face equals 2/3. Happy face equals the tan inverse of 2/3. Wouldn't you know it? Tangents and slopes go very much hand in hand. So, tan inverse, 3 over 2, and the tan inverse of 2 over 3. They got to add up to equal 90, right? So, you get one, you get the other. Just don't mix up the two. This is 1. This is 4. Tangent of star equals 1/4. Subtract that from 90. I think you just noticed it. He's, I don't know. It's picking up his nuts. All right. Let's keep going. What about this angle here? No big deal. 4, 3. This is 3. This is 1. Tangent of the angle equals the ratio. That means the angle equals the tan inverse of that ratio. That means this is going to be the opposite. This will be 1. This will be 3. So happy face will equal the tan inverse of 1/3. You can type in, or you can subtract that angle from 1/8 from 90. Two angles have to be complementary to each other. A 90-degree angle. Yep. Later.